Ahmad, do you want to kick us off?
Oh, I just want to wish everybody a Happy New Year and thank them for their attendance. This is our 36th webinar. And before we get started, we have a couple of announcements in terms of what's about to come, introduction of our speaker today, as well as the format of the seminar. Sean?
Great, thanks, Ahmad. Welcome, everyone, and Happy New Year. So today we're really privileged to have Dennise Templeton with Lawrence Livermore National Lab present. Dennise has recently published a paper, I suspect many have read, a really interesting paper on managing induced seismicity risk from CCS projects. So this is, I know, a topic of great interest to the general community, and will be, I think, of interest to our all. So thank you to Dennise for agreeing to present. And just quickly, before we kind of pass it over to Jens to talk about the schedule, I thought I'd just quickly point out that, it's been an interesting few months of late within the topic of induced seismicity. Just before Christmas, a large significant event in Midland Basin. Over Thanksgiving, we had another large 5.4, I'm sure as everyone knows, in the Delaware side of the Permian Basin. And up in Alberta, there's kind of an interesting interesting earthquake sequence that's a little bit controversial in terms of if it's natural or induced. So there's been a lot of activity of late, and something the committee is looking at how best to find presenters maybe to talk on some of these most recent topical sequences. So with that, I'm going to pass it over to Jens to talk about our upcoming schedule.
Yeah, thanks, Sean. We have one talk schedule coming up and a few potentially in the works, including what Sean was just mentioning related to the big recent earthquakes. And the one talk is by Lei Jin and Bill Curry at ExxonMobil, and they will be talking about a software program, GIST, a geomechanical injection scenario toolkit for rapid analysis of injection-related earthquakes. And of course, that'll be the first Friday of February. So back to the first Friday schedule at normal time, 10 a.m. Central.
Hello, good morning, everyone. This is Mahdi Hattat from the Bureau of Economic Geology. First of all, I brought this statistical distribution of the people in the registration list that we have. The communities divided between industry, academia, and regulatory agencies. As you see here, we have 518 people in our registration list, and the industry is like more than half of our community. That's great news. And after that, we have the academic attendees and then the regulatory agencies attendees. So we ask everyone to share this information about our webinar series with their colleagues that are interested in induced seismicity to have a bigger group of people in our community. For running this webinar more smoothly, we ask everyone to be muted during the talk, but after the formal part of the talk, you can ask the committee to be unmuted, and then you can ask your questions personally. And please submit your questions during or after the talk in the chat button at the bottom of the Zoom meeting window, in order for us to summarize the repetitive questions. And this specific webinar is recorded after consultation with the presenter, and it will be uploaded in our YouTube channel. The link to this YouTube channel is available in the invitation email. And please subscribe to this channel for future notifications about this upload. Without further delay, let's invite Dennise to start the talk. Dennise.
Okay. Can you see my screen?
Yes, we can.
Perfect.
Okay, excellent. Thank you. So hello, good morning, everyone. I'm Dennise Templeton from Lawrence Livermore National Laboratory, and today I wanted to discuss taking a project lifetime approach to the management of induced seismicity at geologic carbon storage sites. So this work is part of US DOE's National Risk Assessment Partnership, which is a collaboration of 5 different national laboratories, in particular NETL, Lawrence Berkeley National Laboratory, Lawrence Livermore National Laboratory, Los Alamos National Laboratory, and Pacific Northwest National Laboratory. So this is a very multidisciplinary project, and we had a lot of people from different labs help out on this. So the goals of NRAP, like this particular partnership, is to aid in the quantification and management of subsurface environmental risks associated with large-scale geologic carbon sequestration. So we're focused on developing and demonstrating science-based methods, computational tools, workflows, and recommended practices to quantitatively assess and manage these environmental risks, one of which is, of course, induced seismicity. And I'll list my co-authors here. So Martin Schoenball, Corinne Leyland-Bachman, Bill Foxall, Yves Guglielmi, Kayla Cole, Jeff Burkhart, Bob Dillmore, and Josh White. Okay. So, just to begin, like, what is our big picture here? Why are we taking a project lifetime collaborative approach to induced seismicity risk? So first of all, we just need to develop more carbon storage reservoirs. If we look at some of the research that's coming out, we can see that carbon capture that's being developed right now is overtaking the carbon storage that is being developed right now. So we really need to get on board more carbon storage reservoirs. And these subsurface reservoirs are going to have to be large and possibly have multiple developers in them. So can we, proactively develop a framework that our whole community agrees on what should be included in, proactive assessments and management of induced seismicity? And just to reiterate, all of us here are are interested in induced seismicity. And, part of that is associated with geologic carbon storage, because, when you capture CO2 and bury it back into the ground, you have the possibility of generating induced seismicity. But this is, again, just taking a step back, we're part of a larger community here. We are part of the larger negative emission strategy that includes things like reforestation and carbon sequestration in the soil. So we really need to be talking to each other to determine, like, how many, how much do we need to put forward in order to succeed in our climate goals? Okay, so specifically, how can we address the risk of induced seismicity? So we developed a set of induced seismicity recommended practices. Again, our overall goal is to help facilitate the successful deployment of geologic carbon sequestration projects. We've developed a set of science-based recommended practices, which would proactively address and mitigate potential problems with induced seismicity. But this is really a living document, so we kind of ended our research and collaboration phase, I think at this point about a year ago now. But we really want to take into account, what current research is happening right now. And so we plan to update these recommended practices in, 2 or 3 years and incorporate those new research and case studies. Our audience is subsurface injection operators, regulators, the public, essentially everybody who is a stakeholder for one of these geologic carbon storage sites. And we tried to make it as readable as possible, especially given the subject matter. There's both technical and non-technical issues that are being discussed, in these recommended practices. And it's, again, project-wide and project lifetime issues that are being discussed. And so we really want to facilitate collaboration. We talk about various data sharing aspects, for instance, on how to move geologic carbon storage forward. And so our base methodology is similar to the 2012 DOE, Geothermal Technologies Office Protocol for addressing induced seismicity associated with EGS, but we've modified it to include certain aspects that are specific to carbon storage. And really what we wanted to do here is start a conversation. What do we as scientists and engineers really think are the important things that we need to do to mitigate induced seismicity in carbon storage projects? And can we write them down, especially as we know that these are going to be large projects? What are, what does the science tell us are the best practices right now? And can we agree to, at least consider them upfront? So there's a lot of information in the actual best practices. As mentioned before, there has been a recent manuscript that came out, but there's also a larger technical report that's online. And those, I have links to those two particular documents later on in this talk right here. So I'm not going to be able to go into many details. I'll try to elevate some specific details that might be of interest to this group, but there's going to be a lot that I'm going to have to necessarily gloss over. So just to give a background, some of the things that we talk about are what to do for the preliminary seismic risk screening evaluation, education, outreach, and communication, how to determine what ground motion thresholds should be considered, what seismic data should we be collecting, both before, during, and after injection. What are some best practices right now in terms of hazard evaluation of natural and induced seismic events? How to use that information for a risk-informed decision analysis. And then lastly, what are some best practices for operational management of induced seismicity risk? And as I'll be going through this linearly, obviously, step 1 to step 7, but obviously there's a lot of feedback between these steps. And so it is kind of a circular, essentially a circular approach when we actually implement this. Okay, so for step 1, the preliminary seismic risk screening evaluation. This is something that we're essentially going to be doing later as well. But in terms of dollar signs, we might think of this as a $1 sign operation versus later on when we actually choose one particular site that might be a $3 or $4 dollar sign evaluation. So this is where you have a couple of or several merit candidate sites, and you want to use just some simple methods and acceptability criteria to see if there's any doozies that might come up that might stop the operation. And these can be a variety of things, and we'll discuss them. So that includes like laws, items in your region of concern, stakeholder concerns, things along that nature. The result of this step will be a preliminary assessment for either go, no go for a particular site. So for instance, the first thing is looking at local, state, and federal laws relevant to seismicity. Review prior cases of injection-induced seismicity in comparable operational and geologic settings. For example, there's abundant induced seismicity in Oklahoma associated with wastewater disposal in the Arbuckle group, while there might be, a relative lack of injection-induced seismicity in the Wilson Basin. So ideally, it would be great to get other geologic carbon storage seismicity or non-seismicity, as the case may be. But if that is not available, then we should be looking at other types of fluid injections and looking at regional scale and operational trends. We will also need an initial estimate of the region of concern. And so this is really just a first order generic ground surface area region that could be negatively impacted by the induced seismicity, essentially throughout the lifetime of the project, actually. So we know that the region of concern is governed by many factors in actuality, like the reservoir size, the geology. But here we're just doing a rough estimation. And so we need an estimate of the potential maximum magnitude seismic event, where we expect these events to occur within the subsurface, and then estimate the ground motions associated with those. And so here I have a picture of one of our NRAP tools showing kind of the area of concern. I'll just briefly mention that again NRAP kind of looks at this a little bit holistically. There are several tools that are available online. This is one of them that can, again, very generically produce an initial estimate of concern. These particular recommendations are tool agnostic. And so it doesn't matter, essentially it doesn't matter like what tools you use. We're just suggesting what needs to be the output of those. Okay. We also need to actually look at what the potential impacts to the local community are. And by that, I mean items that could be impacted, either people, places. So for instance, like the population, the infrastructure, if there's local historical sites, for instance, and then get an estimation of the magnitude of the potential impacts. And so we go into some detail as to what the science right now says could be a representative induced seismicity event, a maximum magnitude event, and a representative tectonic event. And this is kind of discussing, trying to help us compare what might happen with induced seismicity and compare it to what people are living with right now in their locations. And then I can't stress this enough, but there needs to be an assessment of local stakeholder risk tolerance so that we can calibrate the risk scale of an individual location. And this is a very delicate process. This is, for scientists and engineers, this is kind of taking a step out of our comfort zone, perhaps, but we really need to think about how our assessments are going to be impacting the local stakeholders. And so like this solicitation process should be planned and carried out with care, ideally by a team with experience in the area of stakeholder engagement. I think the more that we, especially during the pandemic, I feel like the science of something is completely different than how it is perceived by the general public. And so we need to be very careful about how we describe risk is very different from how we describe risk to a technical audience is different than how we need to be talking about risk with a generic, general audience. They need to be the same. We need to be saying the same things, but we have a completely different vocabulary. And so we need to have somebody who is conversant in that. So in the end, we'll have an integrated assessment of the overall preliminary seismic risk based on all of the above factors, and we'll be able to say, can we proceed with planning? Do we need more information? Is this probably not a good site, but we'll keep it on the back burner, or definitely do not proceed. Okay, step 2 is outreach and communication, and I really want to reiterate that outreach, education, communication is going to be key for any of these sites. And so we discuss how we want to incorporate an induced seismicity component to a project's general outreach and communication program. And this is to facilitate communication and maintain positive relationships with the stakeholders, including the local communities. So we discuss how to, like the framework of creating a tailor-made approach for each site based on the individual stakeholder needs, and concerns across all stages of planning, operation, decommission. So we start off with recommending a very broad-based participatory process, and this should really start at step 1, that we need to be talking to the local communities, the governmental agencies, the tribal governments, public safety officials, regulators, others. We need to discuss, why we're doing this, what are the broad societal goals, but also discuss how this will help local stakeholder needs as well. We need to essentially get stakeholder consensus of the project plan. So this isn't assuming that 100% of the people are going to agree, but just that, we can go together as a group, give them general information, but also seismic related information. Communicate that stringent safety standards are going to be met. And this is the first part where we have some kind of a feedback loop. So we can include things in the risk-based mitigation plan that are important to the stakeholders, either activities or communication styles. All that is going to be site specific. We need to have a commitment to fully address potential negative aspects of the project with the stakeholders. We don't go there's many ways of doing this, and again, there needs to be communication to determine what is appropriate for a particular site. And this is the most important aspect, which is the developers and those stakeholders need to continually work and communicate to develop and maintain stakeholder trust. The next part is looking at ground motion thresholds. Which ones are important at the bare bones? So we want to determine site-specific ground motion thresholds to minimize nuisance and damage risks to the local community. So we're going to review, we're going to suggest that people review the local ordinances, building damage criteria, interference with community industrial activities, for instance, the human perception of ground vibrations, and various stakeholder tolerances. So for instance, we recommend reviewing existing standards and criteria. So just as a for example, what are the CGVs for humans to be able to barely percept the source, have it be strongly perceptible, or have it be severe. There needs to be an assessment of site-specific conditions. And so we list what kinds of conditions we're talking about. So that includes, buildings and structure types. Are there any special activities that are happening, medical or research or different equipment? And then also take a look at the existing environmental conditions. So just as a for example, the building codes in California are probably completely different to the building codes in regions that have not typically had natural tectonic seismicity. And so those need to be taken into account as well. So when we take all of that, we can designate at least 4 site-specific ground motion thresholds. So the first one is human perception. If there's too many induced seismic events that are perceptible by humans, this will cause nuisance. And then the local stakeholders will sour to the activities that are happening. We need to determine what are the cosmetic and structural damage thresholds for the buildings in our area. See if there's going to be any thresholds for the disruption of special activities or equipment, and then if there's any regulations. In terms of local seismic monitoring, we need to create a seismic network and information database for induced seismicity mitigation, and also for reservoir management purposes during the operation. So our approach is to determine a site-specific optimal network design, determine what minimum data processing should be necessary, and ahead of time talk about data storage and longevity requirements. So this will help with both communication of risk, or if there's seismic events of concern, like how are we going to communicate that out? The result will be, seismic data to aid in the design, but also the operation of the overall project. Okay, so what existing seismic activity before operations should all operators be looking at? So we talk about earthquake catalogs, we talk about historical records, looking at fault maps and paleoseismic studies, obviously looking at previous induced seismicity, and potentially gathering new seismic data. We also talk about how to determine the best seismic monitoring network design. Again, here, this is an example of one of the simple tools that are coming out of NRAP for how to determine what your seismic network should look like. But this can be done with any different tools. Determining the operation of the seismic monitoring network before, during, and after injection operations should be discussed ahead of time. What are the data processing requirements, and what are the data and data product archive plans? In the documents and in the reports themselves, we do make some specific recommendations based on science-based opinions, science-based research. And so we want to make sure, again, this is even for some of these technical topics, we want to make sure that we discuss these ahead of time, and that all stakeholders are involved and agree to them. So Public reporting and engagement. What data products are going to be made available and when? What data products should we have in near real time? Catalogs, waveforms, that sort of thing. And what can be done on an annual basis? What reporting can be done on an annual basis? So for step 5, we talk about how to quantify natural and induced seismic hazards. So the goal here is to estimate the ground shaking hazard due to natural and induced seismicity at a proposed site. We want to look at both tectonic and induced seismic hazards using probabilistic methods. For the tectonic part of it is, we want to make sure that our facilities are going to be safe from tectonic hazards. We need to be storing carbon dioxide in the subsurface for an appreciable period of time. And so we want to make sure that there's no natural events that could harm the reservoir, for instance. We also want to look at, obviously, the induced seismic hazard, but we also want to be able to compare different seismic hazards. The stakeholders on the ground, the local communities, have already essentially accepted the tectonic hazards that are at their site. And how does that compare? Is it greater or less? The new induced seismicity seismic hazards, for instance. So the result here is kind of an evaluation of the potential increase in the seismic hazards due to the site activities. There's a lot of information here. I will just briefly do an overview. We're essentially suggesting that probabilistic seismic hazard assessments should be done at the reservoir sites. We understand, especially in the beginning, that this is problematic because of the lack of information. Nonetheless, there's pseudo probabilistic seismic hazard assessment methods that can be done, and we would recommend those. So for instance, for the PSHA, we'll need spatial, temporal, frequency, magnitude distribution models for each of the site sources. We'll need a site-appropriate ground motion model for earthquakes as a function of at least the magnitude and the travel path. We'll need local site response information. So again, we can think of this as more than $1 sign. And we'll generate the seismic hazard curve. So this would be the level of expected ground motion, a particular parameter that has a probability of being exceeded during a specific time interval at a particular location. And so what that time interval should be, we don't specifically suggest anything, but we do suggest that everybody be on board with that value. Hazard maps by the USGS could be one method that we can start looking at this PSHA, tectonic PSHA. So when we start talking about the additional hazard from induced seismicity, we're talking about probabilistic short-term ground shaking hazard forecast. So the differences from the PSHA analysis of the tectonic arise that the slip on the faults and the fractures may be induced by the injection program, due to changes in the stress from pore pressure changes, due to pore pressure changes. So the earthquake sources might be a little bit different. In terms of the spatial, temporal, and earthquake occurrence models, we discussed, perhaps it'd be a good idea to move beyond the conventional Smithsonian model and consider earthquake occurrence that varies in space and time. Not easy, we recognize. And we also want to recognize that the range of the minimum and maximum magnitude events of concern for induced seismic hazard may be different, although we strongly suggest that the minimum or the smallest minimum magnitude event should be the same in both analyses. So for both the tectonic and the induced seismic events. In terms of the site-appropriate ground motion models, again, for induced seismicity and for the tectonic seismicity, we recommend that they're the same or similar. And we recognize that this is a big ask. So we need to, or we could, just verify that for common magnitudes and depths, that the two yield comparable predictions. So there should be a lot of communication. Again, I think communication is the biggest term in this whole project here. But there needs to be good communication between the people who are doing the tectonic hazard and the induced seismicity hazard. So the output here is, hazard curves and maps for lowest annual frequency. Sorry, I think the output is going to be the hazard curves and the hazard maps, and they should be common between the two analyses. They should be, for the induced seismicity hazard, the update should be done at least annually or more frequently if there's new information, for instance. Step 6 is the risk-informed decision analysis. What we are talking about here is taking the hazard information from step 6 and using that to do a risk-informed decision on either operational or the design of the proposed geologic carbon storage site. So this will be a feedback. It's not going to be a one-time thing. We're going to want to look at the hazards based on our operations, for instance, determine what the risk is, determine what the vulnerabilities are, and then see if that is acceptable for the stakeholders, for instance. So we're going to do the goal here is to have a rigorous quantitative estimate of the time-dependent induced seismicity risk associated with the design, operation, and closure of the proposed geologic carbon storage site. So we're going to estimate the risk based on the probable damage of particular items, I should say. So these might either be a particular building or set of buildings, sleep deprivation, nuisance, socioeconomic impact for a given seismic ground motion and the probability that this ground motion would occur. Again, these items of importance are going to be based on communications that are happening between the developer and the various stakeholders, other stakeholders. So the result is going to be a determination of the potential future negative effects of the operation and if they're in line with the tolerance ranges of the stakeholders. Okay, so seismic risk from natural seismicity. We want to look at the seismic hazard from the previous analysis, do a more rigorous identification of the people, assets, and activities that could be adversely affected. So take a look at the population centers. Are there sports centers? Are there medical activities that could be adversely affected? And then determine the vulnerability potential of these people, assets, and activities. And so these can take the form of various different methods. We need to quantify the seismic risk. There's a number of different ways of doing that. So looking at the mean annualized loss, which is the mean annual frequency with which the loss in question occurs, the mean annual number of buildings damaged, the probable maximum loss, the local personal risk metric. There's many different ways that we can quantify the seismic risk, but the most important is to have a conversation, identify what's on the table, have a conversation between the people who are actually doing the science, identifying the risk, and moving that through the communication team to make sure that all the stakeholders agree that this is what we should be focusing on. Then we want to take a look at the seismic risk from induced seismicity. So again, we take the seismic hazard from the previous analysis of the induced seismicity. We identify the people, assets, and activities. This should be the same as for the natural seismicity. We want to identify the vulnerability potential. There's a similar methodology of doing it, although the models are different for natural seismicity and induced seismicity. And then we want to quantify the seismic risk, which is similar for the two, natural versus induced. And then we want to have a risk-informed decision analysis. So the project planning should occur alongside the risk-informed decision analysis. And updates, especially in the beginning during the design phase, may come fairly often as new information becomes available, or as like during the first year of operation as new technical parameters become available. We want to have a clear description of the uncertainties as well. Okay, step 7 is the operational management of induced seismicity risk. So the goal here is to create a site-specific real-time plan to monitor, assess, control, and mitigate the risks associated with induced seismicity. Our approach here is to establish a plan describing, what direct mitigation actions, for instance, pressure, and indirect mitigation actions should be implemented. And by that, indirect mitigation actions are, for instance, insurance, and under what conditions. So we talk about traffic light systems. Some of them are based on levels of shaking, for instance, or observed magnitude events. There's also adaptive traffic light systems. The result of this particular step is going to be a clear set of procedures known and approved by all the stakeholders ahead of time to be followed in the event of a certain, seismic thresholds are reached, whatever those thresholds happen to be. So, for instance, for an adaptive traffic light system, we have real-time monitoring feeding into rapid hazard analysis, which feeds into a rapid risk analysis. We can have a list of observations or results that would increase the level from green to yellow to red, and a set of actions that would require the modification both of the operation and of the communication to the stakeholders. We also recommend an expert panel. So this expert panel would provide evidence-based information and recommendations pertaining to the induced seismicity risk. So we want to create and promote a forum in which the operator, the regulatory agency, other stakeholders, other local stakeholders, for instance, independent subject matter experts, can be able to come together and monitor and assess the induced seismicity that's being observed, develop recommendations for operational responses to that induced seismicity. And this is especially important when we have overlapping regions of concerns. If one operator is injecting in a certain area, but the region of concern overlaps with another operator, how can we facilitate the communication, collaboration, and flow of information? We stress that there's going to be an early evaluation period. We suggest that's going to be about, for the first year of injection. The relative changes in pressure and stress are going to be at their greatest. And we also know that we're going to have an incomplete knowledge of the subsurface. And so how can we proactively decide what we need to do during this early evaluation period? So we discussed how injection operations should be gradually increased, and that any increases in the planned injection rate should be recommended by the expert panel. We discussed what should be done post-closure. So the monitoring analysis should continue until there's stabilization of the pressure and stress to the steady state values, and that there's a clear demonstration that the seismic magnitude frequency behavior is approaching baseline tectonic conditions. I mentioned again liability and insurance. There needs to be a discussion for what coverage is going to be available for damages caused by induced seismicity, and that should be included in the induced seismicity mitigation plan. Again, that's going to be the last means of indirect mitigation. Everything that we're talking about here in steps, like 1 through 7, essentially, is how to not have induced seismicity that impacts the surface population or the subsurface infrastructure. So if we do get something that does causes damage, that that we also need to take into consideration, although we should plan for that not to happen. We also need a plan for damages resulting from induced seismicity in a shared region of concern. So again, we don't talk about specifics here, but we do talk about that there needs to be a discussion about that ahead of time. So in summary, we're talking about developing a set of recommended practices to address and mitigate potential problems with induced seismicity. We describe, a general 7-step program to enable the safe and economic implementation of geologic carbon sequestration with induced seismicity. These are based on a set of science-based recommendations based on literature and FME input. The technical report is online, as is the manuscript. So both were peer-reviewed outside of the NRAP group by people in academia and in industry. So we wanted to make sure that we got a broad view as possible for the current state of the art as of a year ago, essentially now. The path forward is to, for the recommended practices, we want to update the science every few years to include any recent lessons learned, case studies, other best practices based on new research and development. We really see this as a living document, and we see this more as facilitating communication on both technical and non-technical issues over a wide range of stakeholders. So this is, like the local community, local safety officers, the technical experts who are included in the site and who are not included in the site. How can we develop a set of practices that we all agree to ahead of time are the best practices, and that we can consider them for each individual site? I will reiterate that there's no one size fits all for each of these sites. So we really want to just develop a framework and a process that we can communicate to each other. And I'd like to, thank my sponsors, for instance, DOE, and thank you. Great.
Great, thanks, Dennise, for a really kind of interesting overview and a comprehensive overview, cradle to grave, so to speak. So thank you for that. So if anybody has any questions, feel free to put it into the chat, and we can kind of go through it. So there is one from Colin Sayers at the moment. He's requesting links to the this report and the manuscript. Dennise, if you wouldn't mind putting it into the chat. I think there's probably several people in the audience that'd be interested in seeing that. And while people are kind of thinking of questions, I'll maybe kind of kick it off if I can, if you're able to multitask, Dennise. I'm curious, there's best practices, thank you. There's best practices out there for geothermal, for instance, and I'm sure you're aware of and leveraged for the development of these for CCS. And I guess I'm wondering, are you seeing any, where would there be significant differences between the two? Is there, what's kind of unique to the CCS problem, maybe from other forms of injection that you think are important to address, and how have they been addressed in the framework?
Yeah, that's a really great question. And I've talked about, communication before. I think because on one hand, geologic carbon sequestration is going to be bigger. There's going to be significantly more stakeholders involved, more different potentially, regulatory issues involved. That communication is going to be really important, which honestly, when I started this journey, coming back, I'm a seismologist. I'm looking at, like how to mitigate the hazard, trying to evaluate the hazard, trying to determine like what our seismic network should be. And then when we started putting everything together, we recognized that, the climate change issue is ginormous. And that, if we really want to make a difference here, to put our technical skills to help this, very broad societal issue, that we need to facilitate the development of geologic carbon storage sites. And so one of the biggest issues is honestly going to be communication. How do we communicate the risk? I think that is different from EGS in that it's just, each site is smaller. Like the stakeholders involved are much more localized. When we look at geologic carbon storage sites, there's just going to be a lot more stakeholders. There's going to be a lot more people asking questions. And there's going to be a lot more lay people interested in what's going on here as well. And so I think I kind of always come back to this news article I read about how Amazon, for instance, wanted to create, a large warehouse in New York. And essentially the local stakeholders put a stop to it because there wasn't enough communication between, it's not exactly science, but, it's like between what the corporation was expecting and what the local community was expecting. And so, we can do the best science and technology and engineering that we can to ensure that the site is going to be as safe as possible, and that we feel really confident in engineering that we're doing. But if we don't communicate that out, if we don't have like good teamwork, if the scientists can't communicate to the communication specialists, who need to communicate to the lay leaders. I think that I see as honestly one of the largest roadblocks in our way here.
Great. Thanks for that, Dennise. And so I see Julian Balmer has put actually a copy of the, I don't know if it's a link or a copy of the manuscript on the chat window as well. So I think Julian had done one of these webinars for us a few months ago and had actually pointed out your paper that was kind of hot off the press, I think. So I think you have a fan out there, Dennise. Again, I'd encourage people to put their questions, but I'll maybe, if I could, follow up on that same question. So I completely agree that the communication is critical, and quite frankly, I think if we look back, this has come up a number of times in the ARMA webinar series. How do we communicate the great science that's being done to the lay people, the stakeholders, and damage, as well? As you nicely kind of framed at one point, the perception, the public perception of felt seismicity, nuisance seismicity that we unfortunately label it. But what are your thoughts on there's a communication part, but what struck me from your presentation, the idea you nicely framed up front, you're going to have a lot of uncertainty in the subsurface, injection pressures, stress, and during the first year, some clarity, hopefully, on those aspects. And I think quite often we're communication-wise waiting to communicate to stakeholders once there's a problem. Do you have any thoughts on sort of proactive communication of that as that knowledge solidifies up front, and maybe before it becomes a problem where people are feeling, or hopefully not damaging events, but how can, at the non-damaging, non-felt point, how can we communicate that background monitoring maybe better to the general stakeholders?
Right. I think that's one of the things we try to do, especially with our expert panel, for instance. And it's called, it's like we ended up calling it an expert panel, but really it should include stakeholders. So that it's going to include local stakeholders as well, that we think would be important. And that would be one communication mechanism. It's like, I feel like there's a lot of small, we're talking about seismic events, like there's a lot of small indicators that something might be happening that, maybe we want to be looking at ahead of time, and we can start discussing that in that forum there. That's going to include, a whole range of stakeholders. So that might be one mechanism that might be easy or easier to have a wide variety of people involved in, discussing some of these, concerning trends in seismicity that, it's like we weren't expecting the seismicity to go in that direction, but it is. Is that a concern right now, or it's going faster than expected? Having a forum where we can talk about, issues like that ahead of time, I think is, as you say, very important. And then making sure that we have a wide variety of people who are involved in discussing these issues, I think is also important.
Great. So on the chat window, we have actually a great question from Julian Balmer. So Julian's wondering, how do we treat differences between natural and induced seismicity? And there's been, as I'm sure you're aware, publications pointing to potential differences in stress drops, etc. And be interested in hearing your comments on that.
Yeah, honestly, I think it's an interesting point. To date, the biggest pushback we've had on that particular issue is that it's super hard. I don't know about this, that there's just not enough information in order to do it, or like it kind of comes up against the state of art of what we can do right now. There hasn't been a lot there hasn't been a lot that comes to my ears that I've seen from other issues. So that's an interesting comment. Okay.
Yeah. So, and Julian, if you'd like to unmute yourself, Julian, and
okay, sorry, yeah, it seems strange to be. So yeah, I agree with everything you said, Dennise. I liked it very much. As Sean said, I'm already a fan of the paper. But so you said, that you should have equations, GM ground motion equations, which for the same scenario. So for similar magnitude at the epicenter, we should be getting comparable ground motions. And then, and I agree with that, but there are some people who say, no, we're going to get much higher motions from the induced earthquakes. And then they argue that because of that, we should be using a much lower minimum magnitude for the induced earthquakes. And then once you do that, then you do an apples and oranges comparison, and you'll nearly always make the induced seismicity look worse than the background. So I was interested if you've come across opposition to that concept that they should be treated the same.
So we're asking that the ground motion models be similar as well, or at least produce similar results for similar, edge cases.
Right.
And that we realize that's going to be the big ask. And so once you have that, then I feel like we really are comparing apples to apples in that particular case. And I guess the second part of your question is, like we do ask the M min value should be the same, but not the M max.
Okay, I thought you said that. I just wasn't sure. So yeah, I also, okay, I'm fully aligned. Thank you.
And if I could follow up, maybe just as a point of clarification. So we're saying the ground motion equations would be the same, but obviously we likely expect the depth of the natural seismicity and induced seismicity to be very different, and induced seismicity to potentially be shallower again, and beyond sort of the magnitude question, potentially amplifying the ground motion. Sorry, I'm being Captain Obvious here, I know.
And I want to highlight this conversation that Julian and I are having here. That one of the things that kind of surprised me when we put this together is how multidisciplinary this set of recommendations have to be. Again, cradle to grave, in order to really assess, manage, and take care of the induced seismic risk at a site. And so I really want to encourage you, everybody who's here, as an SME, to take a look at your portion of that you see yourself in these recommendations. It's like, is there something that you think we should be adding, or as Julian said, should we be concerned about that maybe other people won't agree with us? And feel free to email me about it. Because I feel like what we're trying to do here is develop consensus amongst the scientific community as to what we should be proposing to regulators, to the non-scientific community, to show that these are the actions that need to be happening in order to have a safe and an economic carbon storage site. The benefits are huge, and we want to make sure that we have again, consensus amongst this group. That's one of the reasons why each of the steps in the recommended practices had multiple outside peer reviewers, so people who weren't part of NRAP, part of that national laboratory environment, because we really wanted to go outside of our comfort zone and reach out to different people.
Excellent. Well, unless anybody has anything further to ask, I guess we've got about 5 minutes here to kind of wrap up. But I apologize for asking questions, but it's an intriguing subject, and you've done such a great comprehensive job putting this together, Dennise. I guess following on from that comment you just made, an obvious question to me is, so you describe this as recommended practices. I think everybody would like to see best practices to point towards. Can you give any comments on what we need to do, that input that you're just describing commenting on recommended practices, obviously a critical part, but any further comments on moving this towards best practices?
So I think one of the things, and I think you highlighted my point of communication. You know, we're using the same words, but what does it mean? And it's kind of funny that you mentioned that, because we did go back and forth on recommended practices versus best practices. And in the end, we wanted to say that, you know, best practices is something that's going to happen in, 50 years when we got all the kinks out and we have, gigantic stores of carbon dioxide already, and that we have safely learned already how to manage that. And so we ended up scaling it back to recommended practices, and then just kind of extrapolating in the text saying this is, what the science tells us right now is the best things we can do. And so, like in the preliminary phases, I think that's kind of why we did that.
Great. And then
This is Kate Baker, and I have a question or
ahead,
comment.
yeah, go ahead, Kate.
I've heard the word communication quite a bit here, and I actually think it's beyond that, because when you talk about communicating with the public, you're not actually trying to communicate with them. You're trying to change beliefs of the people who are not in my backyard types. And I would submit that the only way that you can change someone's belief is to change their experience, and that's very hard. The other thing that I think it's important to remember is that the most listened to radio station in the world is WIIFM. What's in it for me? So I just would like to put that in the room as people think about how do we engage with the non-scientific stakeholders who live and work in the areas where we're proposing these sequestration projects. Thanks.
Thank you. Yes, I agree. I'll just very quickly point to your second part, which is, I'm sorry, I just had a brain fart. We were.
What's in it for me?
There you go. What's in it for me? Yes. Sorry. Wow. Okay. Yeah. So that's actually something that we do touch on. There's social science methods, people who are trained in this, to talk about how can we mesh broad societal goals. Carbon. Like the issue with too much carbon in our atmosphere, and how that can help the local community. So this is, why we need to ensure that, everybody involved knows what's important to the local community. Is that, jobs? Is that, something else? Is that, just funds? It's like, I think at some point, like some of the, like there's discussions about ensuring, for instance, for reforestation, can we pay people to keep their, trees in a certain area? So, like what is it that's going to be important for the local community, and can we, address that and ensure that, we're both on the same page? We both might be doing something for different reasons, but as long as we're doing it together, and that we both agree that we want to do, X, Y, Z, I think that's definitely going to be important. And yes, we're going to have to take into account, what the local community's needs are as well.
And I'm a fan of all of this, I want to add.
Great. Well, we've reached the end of the hour allotted time. So let's kind of wrap it up. But so first of all, on behalf of ARMA, Dennise, I'd like to, and the Induced Seismicity community here, I'd like to thank you for the excellent work and the very nice presentation of this comprehensive piece of work. So thank you for joining us. And again, happy 2023 to all the participants here. And just a reminder that our next webinar is going to be February 3rd. You'll see emails coming out from Madi with invitations and reminders for that in the coming weeks, but be another interesting talk. It's by Bill Curry and Jim Lee at ExxonMobil, talking about an interesting fast analysis for causation of induced seismicity. So be of great interest. So I'd encourage everybody to attend. So with that, thank you, everyone, and we hope to see you next month. And again, Dennise, thank you so much for participating, providing the webinar, and greatly appreciate it. Keep up the good work.
Okay, thank you for this opportunity.
So Dennise, often I'm going to go looking for the WII channel on the FM dial that Kate was pointing out. We often kind of wrap up with more of a informal period of discussion. I don't know if there's anybody that has other questions or comments, but if anybody does, and Dennise, if you have a few minutes to stick around for a few minutes, I'd welcome anyone to unmute and ask Dennise any questions they have, if you're willing, Dennise.
Yes, that sounds good. And I saw Ivan's comment in the chat. Yeah, I think I had seen the studies that were coming out, especially in California, because Livermore is included in those, trying to identify, potential CCUS sites within the Great Valley of California, for instance. But I have not seen some of these north central and northeastern U.S. Potential CCUS sites. So I'd be interested in seeing output from that as well. Thank you.
Yeah, sorry, Ivan, I saw the comment there. I meant to point to it, but got a little distracted there. But Ivan, do you want to unmute, and is there any other details you can provide on that DOE project you're involved in? I guess the answer is either no, or Ivan doesn't know he's still muted. Or distracted, perhaps. All right, well, no need for an awkward online time here. Again, if anybody's got any other questions for Dennise, feel free. Otherwise, I guess we can wrap this up. And again, thanks, Dennise. This was really good and very topical and very well presented. As I think the lack of questions is more on the clarity side versus the interest side, for sure.
Yeah, I think there's a lot of information here and a lot of different subject matters, which takes a little bit of time to kind of digest, I would say.
For
Hi,
sure.
Dennise. Quick question, Dennise. I'm Jorge Barrios from Batel. I don't know if you remember me.
Yes.
Yeah, it is possible to get this presentation with our entire team.
Yeah, I can email that out.
For sure. I will make arrangements.
Sounds good.
Great.
Thank you.
All right. Well, thank you, everyone. And thanks again, Dennise.
Okay, great. Thank you. Bye.
Thank you so much, Dennise. Good presentation. Thank you. I enjoyed it. Thank you.
Great.
Have a
Thank you.
great weekend.
Thanks.